Hey everybody, it's Mr. N, and we are going to talk about indefinite integrals and the net change theorem today. All right, so what is an indefinite integral? Well, it's when we have our integral over here without any bounds on it. So notice there is no a or b bounds on this. So now without the bounds, when I integrate, I cannot plug anything back into x, so my final answer will have a plus c in it, where c is some sort of constant. So this is an indefinite integral. So over here, when we integrate, we will get capital F of x. So f prime of x equals f of x. And here's our example. If I integrate x squared, I'll get 1/3 x cubed. Now, since there are no bounds, I will have to put plus c. You always need to put the plus c. Plus c, that is our constant. If I take the derivative of this, notice if I take the derivative of my constant, that will go away, and I'll just be left with my original, which was x squared. All right. Again, if I have a or b, I will get a number. So if it is bounded, my final solution is a number. If it is not bounded and indefinite, this is definite, this is indefinite. So if it's indefinite, no bounds on it, I will get a function, okay, or a family of functions. So you'll get a function plus c, which would be your constant. So some important integrals to just remember. Over here, we have the integral of a constant times f of x. You could take the constant out in front, and then you just integrate the f of x. Over here we said, and these are things that we've talked about, we said the integral is a distributable function, so operation I should say, so you can distribute that integral and do each one separate. You can either do it with addition or subtraction. The integral of a constant k would just be k times x plus c, always plus c. Over here, this is what we have as our power rule. So this would be like x squared, x to the third. We have x to the n plus 1 over n plus 1 plus c. Now we've done these with guess and check. Now this is kind of like the formal way. You take the power, you add 1 to it, and then you divide it by whatever that power was plus 1, and then plus c. The integral of sine is negative cosine. Cosine is sine, again, plus the c's. The integral of secant squared is tangent x plus c. Cosecant squared would be negative cotangent x plus c. Secant x tangent x would be secant x plus c. And the integral of cosecant x cotangent x is negative cosecant x plus c. These I had you memorize prior, but it's a very good idea to memorize them again and make sure you know them. And when we assume for indefinite, that is only valid on a continuous interval. And now we have this thing called the net change theorem. And the net change theorem tells us that the integral of a rate of change is the net change. So if I integrate from a to b, definite integral of f prime of x dx, I'll get f of b minus f of a. Now this was part of FTC, remember? So here's an example that we have. If v of t is a volume at time t, v prime of t is the rate at which the water flows in. So if I integrate from time 1 to time 2 of this volume vt dt, I will get vt2 minus vt1. So that just tells us we're plugging the bounds in. Again, that's from FTC, and that equals the change. So this whole thing is the change in the amount of water from t1 to t2. If I do it with position, v prime of t equals, or v of t equals s prime of t. So if I integrate the velocity from time equals 1 to time equals 2, I will get the net change in position from t2 to t1. All right, let's take a look at what else we have here. Moving on. And we've got the same example with acceleration. If I take acceleration and I take a of t, that's going to be the derivative of the velocity. So if I integrate the acceleration, I will get the net change in velocity. So let's go ahead and do these examples. We only have a few today, and I'm going to do a few more in class. So number 1 says the integral of cosine x minus 3x squared dx. So we can do this each separately. I could integrate the cosine and then this one, the 3x squared. Integrate cosine gives me sine x, and then integrating 3x squared is going to give me just x cubed plus c because it is indefinite. Next, over here, I've got the integral of x to the negative 2. So I'm going to rewrite this to be well, let's just go ahead and keep it like that because it's probably easier. But we know when we add 1, we're going to get x to the negative 1, so I'm going to need a negative 1 out in front, and that'll be plus c as well. So I can rewrite this as 1 over x plus c. And then the last one over here, for number 3, I'm going to integrate the t squared. I will get t cubed. I need a 1/3 out in front, minus, and this is t to the negative 2, and that's similar to what we just did over here. So that's going to give me negative t to the negative 1 plus c. And just cleaning this up, I'm going to rewrite it as 1/3 t cubed plus 1 over t plus c. All right, and for the next one, we have the integral of 3x to the 4th minus 2x to the negative 3rd plus the secant squared x dx. Okay, so let's take a look at this. Over here, we'll do one part at a time. For this first part, that'll be x to the 5th. And since I need a 3 out here and I need to get rid of that 5, I'm going to make that 3/5 out front. I'm just using a guess and check technique. Or you could use the power rule if you want. That's fine as well. Over here on this next one, this is going to be when I add 1 to it, right? When we integrate, that'll be to the negative 2. So I'll already have what I need there, so that's all set. So I just need to put a plus. Over here, the integral of secant squared x, we memorize this one to be plus, that's going to be tangent x plus c. Okay, let's move on to the last problem for this set. And let's take a look at what we got. Over here it says, suppose a particle moves on a coordinate line so that its velocity time t, v of t equals t squared minus, let me write it over here so we can see it a little bit clearer, t squared minus 2t. That's what we're looking at, t squared minus 2t. Find the displacement. Okay, so displacement, and the next one says distance traveled. Those are two different things, and we've talked about it. Displacement is pretty much where did I end up from when I started, and the distance traveled is how far have I gone, which means you have to take, if I moved forward 5 steps and backwards 2 steps, I've traveled a total of 7 steps. That would be the total traveled distance. Okay, so let's take a look at this. So to find the displacement for part A, all I need to do is integrate the velocity over the time integral that we have here from 0 to 3, which tells us from 0 to 3. So that's all I need to do for this one. So this becomes the integral from 0 to 3 of t squared minus 2t dt. And that becomes t to the 3rd, 1/3, minus, and this will be t squared on the bounds from 0 to 3. When I put in 3, I get 9. 27 divided by 3 is 9, minus 9, and then 0 obviously will give me 0 minus 0, so the total displacement is 0 meters. For part B, what I need to do on part B, I need to know when it's moving forward and when it's moving backwards. So let's go ahead and take our velocity and set it equal to 0 to get those critical points. So 2t squared minus t, I'm going to take, or t squared minus 2t, sorry, that's the equation. So I'm going to take a t out, and I'm going to be left with t minus 2. And I'm setting this equal to 0. So that means t equals 0 and t equals 2. Now let's examine these on a number line. Right here is 0, right here is 2. I don't need to go beyond 0 to the left of 0, okay? And I need to go out to 3 as where I'm heading. So let's take a look at these various ones. When I look at the interval between 0 and 2 and I put a value in v of t, okay, I'm putting a value in v of t, I'm going to get negatives. Right? When I put in 1, say, I'll get 1 minus 2, that's negative. When I look between the value from 2 to 3, like 2.5, I will get positives, okay? So that tells me that it's moving backwards here, and it's moving forward here. So I need to break my integral up because I need the integral of the absolute value of t dt, like that. because I need to know when it's moving forward, when it's moving backwards, break up those components to add them separately together. So that means my integral will be backwards from 0 to 2, and I'll put a negative out here because I need to change that. Or we can maybe leave that if you want and just say the absolute value of this, t squared minus 2t dt. It's probably easier for you to understand it that way. Plus, this one I don't need absolute value because I'm from 2 to 3. I know I'm moving forward. It's going to give me a positive answer anyway of t squared minus 2t dt. Okay, so for this first one, when I integrate, I'm going to get the 1/3 t cubed minus t squared, and this will be on the bounds from 0 to 2. And remember, I need this absolute value. Okay, so over here, this will give me 4/3. It's going to be negative, but then we need the absolute value, so I'll get 4/3 as positive. Over here, on this one, I'll have 1/3 t cubed minus t squared, and I will end up with 4/3 as well when I plug in the bounds from 2 to 3. So 4/3 plus 4/3 gives me 8/3 meters on this one that I have traveled. So I had to break it up into the forward and backward components, take the absolute value, so I get the total distance traveled. All right, so thanks for watching. Hit that like and subscribe button. We'll do more examples in class, and I'll see you guys in the next video.